welcome back. If you haven't already, I need you to first watch our simple probability video and then our independent events video, because our lessons this week are going to be building on top of each other. Today we're going to be moving into dependent events, and I hope you're excited to get to work. Let's go. All right, so let's get started. Today we're going to be talking about dependent events. And this is what was really tricky for y'all in class, and I hope this video really helps. Let's start by looking at the keywords. Keywords for dependent events are without replacement, keeping it, or like I like to say, eating it, okay? So really any time that we're taking something away and we're not putting it back before we do our next thing, okay? I added a little note in here. So how do we know that it's a dependent event? Dependent events are going to pull from the same sample space because you're having to remove something from the circle without putting it back. And that is what makes it affect the next event, because you've changed what you have as a choice. Okay? Things to think about, it's like if you were pulling from a pile of clothes or a bag of candy. Remember back to our Skittles lab, all right? And then over here, I made note again that and, comma, and then they all are still gonna mean multiply, but the only difference when we multiply is every time we add another event, we're gonna have to subtract 1 from our denominator, okay? So right here, I have our probability of pink, comma, green, then blue. So we're going to do pink times green times blue. And as you see here, when we started, and our probability of pink would be 3 out of 6. Well, now that we've picked a pink one, it's like I took it away. I did not replace it, so I'm not going to draw it back. Now our probability of green is 2 out of 1, 2, 3, 4, 5. And that's where the 5 comes from. And now let's say I pick a green, like I wanted. So to find my probability of blue, it's just 1 out of 1, 2, 3, 4 total marbles left. Okay? And then, just as we did before, we multiply straight across. 3 times 2 is 6, times 1 is 6. 6 times 5 is 30, times 4 is 120. And then we can take 6 over 120 and simplify it down to 1 over 20. All right, I hope this part helps. If you'd like to pause at this section and really let it soak in, that would be great. And now I'm gonna zoom into our paper so we can get some extra practice. All right, so I've gone through and I've highlighted everything of importance in our 2 sections up here. If you want to do so on your own printout, that would be wonderful, or take notes on it on a separate sheet of paper. Moving into our for instance section, we're trying to look at the probability of green then blue without replacement. So here I have 4 green and 2 blue highlighters. All right, so looking at this, our probability of green first is 1, 2, 3, 4 out of 6. Okay, that is probability of green. Now let's say I picked it up and it says without replacement, so I'm not going to put one of my greens back in the pile. Now my probability of blue is 1, 2 out of a total of 1, 2, 3, 4, 5 markers that are left. And that is where we get our denominator dropping down, right here. Okay, because one thing was removed from the sample space. Then, as normal, we're just going to multiply straight across. And we get, oh my word, look at my multiplication typed out on here. I added them like a crazy person. But 4 times 2 is 8, okay? And then 6 times 5 is 30. And 8 over 30 is not going to reduce to 1 over 6, so let's go ahead and fix that as well. Both of these numbers are divisible by 2 though, so 8 divided by 2 would give us 4, and 30 divided by 2 would give us 15. That is our simplified answer. All right, let's move into the extended process section. All right here we have a bag of marbles, and I'm gonna use my penny to cover up whatever we choose first, just so we can visualize it a little better. All right, let's first look at the probability of green and, keyword for multiply, blue. Okay, so first, let's look at our green. We have 1, 2, 3, 4 green out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles. Okay. After that event occurs, we have selected one of our greens, and I'm going to go ahead and cover it up. Now we're looking at the probability of blue. We have 1, 2, 3, 4 blue, but there is only 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles left. As you can see, our denominator dropped by 1. So our answer is going to be 4 times 4, which is 16, over 10 times 9, which is 90. Both these numbers are divisible by 2. If we do 16 divided by 2, we get 8. 90 divided by 2 is 45. And that is our simplified answer. All right, moving on to number 2, we're looking at blue and then red. Remember, then is another keyword for multiplication, so I'm doing blue, then red. All right, first our probability of a blue is 1, 2, 3, 4 out of a total of 10 marbles. Now let's say I've selected one of my blue. Now I need to look at my probability of getting a red. I'm gonna have to draw in pink though because I don't have a red marker. All right, my probability of red is 1, 2 out of a total of 9 marbles left. Then we would do 4 times 2, which is 8, 10 times 9, which is 90. Again, both of these numbers are divisible by 2, and I can simplify. 8 divided by 2 gives me 4. 90 divided by 2 gives me 45. So there is my simplified answer. All right. Now would be a great time to pause the video and attempt number 3 by yourself. Keep in mind that we're getting both red, so think about what that is going to do to our numerator as well. All right, here we're looking for red, comma is key for multiply, red. Looking at our bag of marbles, we have 1, 2 red out of a total of 10 marbles. Now I'm going to use my penny to cover up the one that I picked from the bag. Now as you can see, I only have 1 red left out of a total of 9 marbles. That being said, anytime we're picking the same thing from a dependent event, our numerator is also going to drop. Then here we can do 2 times 1, which is 2, 10 times 9, which is 90. Again, both these numbers are divisible by 2. 2 divided by 2 is 1. Do not tell me it is 0. And 90 divided by 2 is 45. So there is our simplified answer. Now moving into our taking it one step further section, we're going to be talking about a word problem here. In a box of highlighters, there is 5 yellow, 3 pink, 4 blue, and 1 purple. What is the probability of picking a pink, keeping it, and then picking a blue? This should be similar from yesterday's problem with independent, except here we have a keyword, keeping it, which makes it dependent. Okay, as you can see, our box of highlighters is up here. Remember I told you if you don't have the manipulatives in front of you, to find the total number of markers, we just have to add all of these together. So 5 plus 3 plus 4 plus 1 is going to give us 13 total highlighters. All right, now I'm going to write using my parentheses. The question is asking us probability of picking pink. So probability of pink, then blue. So pink, then is a keyword for multiplication, blue. All right, here we can see that our probability of getting a pink is 3 out of 13. 3 out of 13. Now that I've picked this pink marker, it says I'm gonna keep it, so I'm not putting it back in my stack. Now, what is our probability of getting a blue? As we can see, there's 1, 2, 3, 4 blue out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 markers. So our probability of blue was 4 out of 12. Again, we can see that our denominator dropped by 1. Then we multiply straight across. 3 times 4 is 12. 13 times 12 is 156. Both 12 and 156 are actually divisible by 12. So 12 divided by 12 is 1, and 156 divided by 12 is 13. This tells us our chance of picking a pink, then blue marker with keeping the first choice has a 1 out of 13 chance of happening in this particular box of highlighters. That's it for today's video lesson. I hope that helped with understanding dependent events. If you need anything else at all, please message me on It's Learning. This is day 3 of this craziness and I am missing you guys, but I hope you're having a great time and behaving for your parents. Bye.